Hey guys, so what we're going to do today is we're going to talk about and go a little bit in depth of how we evaluate functions. You watched a video a little bit yesterday, but I want to go into it more in my detail today. A function is just a fancy way of saying like a machine. When you input something into the machine and you do something to it, you get a specific output. So, like for this particular machine, it says if I take a three-sided object and I put it into the machine and I want its shape name, what am I going to get out? And the function would say triangle because a shape with three sides is called a triangle. What if I were to say, okay, what about a five-sided object? Well, if I put something with five sides in and I put in what's the shape name, we would come out and say a pentagon. Okay? Now, opposite goes over here. Now we're going to get into mathy things. If I take 10 and I put it into the function machine that says add 4, what would I get as the output? Well, the output would be 10 plus 4 is 14. Same thing would happen if I put the number 15 in. What would happen if I plug 15 into this function machine and I added 4? Well, 15 plus 4 would be 19. So that's what we're talking about today is we're going to be talking about specific functions, but we're not going to have a machine like this. It's going to have different notation, which is called function notation, which I'm going to introduce to you now. So function notation just looks like this. It's saying instead of writing, for example, we talked about in the past y equals 2x or y equals x plus 3. Those are different equations of lines, which we've already been exposed to. But now, instead of writing y, we are going to write f of x. Or instead of y, we might use f of n. Now, the reason why we use n is because that's a letter in our notation of the function. And the reason why we use x here, because x is in that function. If I were to say f of a, we would use a in the function. It all depends on whatever letters we want to use. It doesn't really matter. It's just showing that it's a function of something, and we're doing something to that number to get an output. So that's what we're going to be talking about today. So what I want you to do is I want you to flip it over, and we're going to do a couple examples together. So on the next page, what I'm going to show you is that a function is defined as is. F of x equals 2x, f of n equals n plus 3. We looked at those in the other place. But what if we want to evaluate it? Evaluate means come up with an answer. And I stick a number in there. And they say, what's f of negative 8? All that means is just take the x and replace it with negative 8, plug it in your calculator and get negative 16 as your output. If your input's negative 8, the output's going to be negative 16 into this rule or function machine. Same thing happens over here. I have f of n equals n plus 3. What if I want to find f of 4? That just means input 4 into the function, and for n, add 3 to it. And what do I get out? I get 7. So the input's 4, the output's 7. Okay? So copy this down if you don't have it already, and we're going to practice one on our own. So flip it over.